So our next chapter is light. This chapter is the study of phenomena of reflection and refraction of light using the straight line propagation of light. The first point is reflection. A highly polished surface, which such as mirror, that reflect most of the light falling on it, and this concept is known as reflection. And there are some laws of reflection, like such that the angle of incidence is equal to the angle of reflection. Sorry. So angle I equal to angle R. And the second law is incident ray, reflected ray, and normal at a point of incident all lie on the same plane. The normal is the imaginary line drawn perpendicular to the surface of point of incidence. So here we can see the diagram. Let's say this is the light, and this is this surface, such that mirror. So when when light goes to the mirror, it reflect to the another side. So this is the reflected ray and this is the incident ray, and the normal is the perpendicular here. This point is the normal line point. This is the incident angle and this is the reflected angle. If I equal to 30, then R is also 30. Mirrors whose reflecting surface are spherical called spherical mirrors. There are two types of spherical mirrors. First is concave mirrors, another is convex mirrors. So concave mirrors whose reflecting surface is curved inward like this, and the convex mirror whose spherical reflecting surface is curved outwards like this. The outer side of the mirror will reflect, and in concave the inner side of the mirror will reflect. Here are some important definitions, such as pole is the center of reflecting surface of a spherical mirror denoted by P, and the center of curvature is the center of sphere formed by reflecting surface of a spherical mirror denoted by C. Radius of curvature is the radius of sphere formed by reflecting surface of the spherical mirror denoted by R. Or we can say that R is the distance between point of center to the point of pole. We can see in the diagram, for concave mirror the pole is this point, and the center of curvature is this. That is the when we complete this sphere, there is a center point comes, and this point is the center of curvature, and the distance between C and P is the radius of the curvature. So this is the focus. This point is the focus where incident ray and reflected ray intersect. As you can see, the reflecting surface is inward. So this is the concave mirror, and for convex, points are like principal focus. Pole is this, and principal focus is this point. And because we see that while incident ray comes, these are the incident ray. So when incident ray comes here, so it will reflect outward, not intersect inside, but they go outside because of the shape of the mirror. Because of the shape of the mirror. So now this reflected ray, we have just pointed them like dotted, and the intersection of these points, these imaginary lines, or you can say, is the focus, and the center of curvature is inwards, because when the sphere is complete, when we made the sphere of this mirror, so the center will come inside, and this is the P. F is the focus point where all reflected rays intersect. This one. The distance between pole and principal focus is called focal length. Between this P and this one is the focal length, which is denoted by small f. The diameter of spherical mirror surface that is reflecting is called aperture. This one, M and N. The distance M and N is the aperture of the spherical mirror surface. There is a relationship between radius of curvature and the focal length, that is R equal to 2f, which is used for solving numericals. Now we come to mirror formula. 1 by V is plus 1 by U is equal to 1 by F, where U is the distance of object from the P. P is the pole. V is the distance of image formed from P. from pole to their image is formed on the reflecting surface. The V is the distance of image formed from P. Some sign conventions are also there. So first is all distance measured on the right side of the mirror are positive. Like we can say this one is the mirror, so this one is the axis. So when this side all the in this side all the distance, or like we can say any points that are measured are all are positive, and on this side all are negative. And distance measured above the principal axis, we can say these are all. Magnification is the ratio of height of image to the height of object, represented by letter m, such that m equal to h dash upon h, where h dash is the height of image and h is the height of object. So let's draw a diagram. So here is our concave mirror, and this is our axis. This is point P, and let's say here is our object AB. So when rays go to the mirror, it reflect another ray which passes through the focus. This one is AB. So this is A dash, B dash, and this is the P. This is the F, sorry, P, F. The height of AB is the object height, which is h, and the height of A dash B dash is the height of image, which is h dash. From here also there is another formula. Let's say this one U is the, we have studied like U in the above. We have studied that U is the distance of object from P. Here U is the distance of object. This is the object, and this is from P, and V is the object distance of image from P. So now we can form there is another formula formed like magnification, that is minus V by U. The minus sign in the magnification value indicates the image is real. The positive sign in the magnification value indicates the image is virtual. Our next point is refraction of light. So when traveling from one medium to another, the direction of propagation of light in second medium changes. This phenomena is known as reflection of light. Let's take a glass slab, and let's say the ray is coming, light is coming. We can say here this is the incident ray. This is the normal. So when it go, this is the medium air, this is the another medium, that is glass. So when it goes from open air to glass, the light will, you can say, move away from the normal, and to the end of the surface of the slab there is another normal point, and here the reflected ray is closer to the normal. So we can say that this phenomena is the refraction of light. Next is, there are some laws of refraction also, like reflection, and the first refraction law is the incident ray, refracted ray, and the normal at the point of incident all lie on the same plane. This is the same as reflection law. Another law of refraction is ratio of sine of angle of incidence to the sine of angle of refraction is constant. This constant is known as the refractive index, which is denoted by mu. So such that sine I by sine r equal to constant. And this is the important point. Light travels fastest in vacuum with a speed of 3 into 10 to the power 8 meter per second, and this is denoted by c. speed of light. So there is a formula, like there is a relationship between speed of light in air and speed of light in medium, and this is the refractive index of medium, Nm equal to C upon V. Like mirror formula, there is also lens formula. In lens formula, the sign between V and U, between 1 by V and 1 by U changes to minus, but and the sign of magnification in like minus in magnification in mirror formula, value the minus value indicates the real image, but here in lens formula the image is virtual. But if in some cases the image is formed real also, and the height, this height relationship between magnification is same. Let's say h dash is the height of image and h is the height of object. Another next point is power of lens. The power of lens is the reciprocal of focal length in meter. So P is equal to 1 upon F. The SI unit is diopter, denoted by letter D. 1 diopter is equal to 1 upon 1 meter. You can say that. So if P is positive, then the lens is convex, and the if P value is negative, then the lens is concave. This will help in numericals. So you can solve the numericals in the NCERT book chapter light, law, reflection and refraction. So from there you can practice them.